Okay, today we got problem 815 bus route, so we given some bus routes. So that means that bus is going, for example, if bus 0 goes 157, it always cycles through them. We start at source and you want to go to the bus stop target. You can travel between bus stops by buses only. Okay, and then least number of buses you must take to travel from source to target. Okay, so my thinking is that we just model this as a graph problem, and then we have edges of size 1, so we do BFS. Now how to properly do it? What will be the edges and what will be the nodes? Well, the edges should be like if I get to a bus stop, right, then I should be able to go to any bus for 1 that has that, or I should also be able to go to any other. So for example, from 15, right? Well, for 1 I can go here to this bus, and then for 0 I can go to 5 and 4, and basically I want to go to from this to this with least amount of, and since we have edges of 0, 1 weight, we can use 0, 1 BFS, which means that we use DQ and 0 edges go front and 1 edges go back. I guess now question is how many bus routes do we have? Can there be? Probably they're unique is the route. Routes are unique, and we have 10 to 5 of them, and source target 10 to 6. Okay, let's do IPG default, or like IAG default dict, and let's have like a list, and then like 4 are in routes, and then I want to do like so that's G like same, and G other is also default dict, right? And now I go through routes, and now the problem is that no, I just want to save G other, I think. So for enumerate routes, so what I'm doing is that, imagine I start somewhere, right? And then let's say that in the DQ I will store the distance, the node, and the bus I am on, and the distance of the number of buses taken, right? So Q is DQ, right? And then so what I do, well, bus I, right, no, G other, so for J R stop enumerate R, and then we want, so from bus stop RS we can get there by bus I think, okay, maybe. Then we can save like this, and then like, I don't know, if rs source, then q append, and then 0. And let's see, I mean, we always want to jump to, not really, if you jump to same station. So we are on bus I, and okay, so q append, so that's the distance and which bus we are taking. And I guess what stop are we in? Yeah. So let's do rs, right? And now, so like this rs is 1, whatever, right? Okay, and now if not q, return -1, right, in each case, and now while q we do this. So that's current distance, current bus, and current bus stop is q pop left. And now first I gotta go through, so I know which bus I'm on, and then okay, so let's say that, okay, so distance to stop, well, first we go through, we are in bus whatever, right? So we are in like bus CB, right? And then we go for route stop in routes CB. And now if rs equals CBS, then we continue. So route stop is current bus stop, right? Otherwise, right, if it's different, if rs not in dist, then dist rs cb +1. So if R is not okay, so we put it in there. Okay. For dist rscd plus 1, then we want to do q append. No, that's in the oh, because that's the same distance, right? So we do cd cb rs, right? But this way it will be an infinite cycle. So because let's say, so I would go from 4 to 5 because why not, and then from 5 to 4 because why not. So I probably don't want to do that. So I want something smarter, maybe lambda default dict int. And now if r is not in dist or current bus not in dist rs, maybe I can just skip this part. Then we will do like current bus is equal to cd and we append. Maybe that will work, I don't know. And then I guess that's it. And then we need to go through g other of that station. So what other bus we can jump to? So for route stop in g other cbs, right? And now can jump through to there for 1. Now yeah, we also need a pair. So if so if current bus not in dist rs or append left, I have no clue if this will even work. I already so if we are not there, or we can get there on smaller whatever, right? If cb not in dist rs or cd plus 1 is smaller than dist rs cb, then dist rs cb is cd plus 1 q append cd plus 1. No, that's next bus. And if next bus not in dist current bus stop or cd plus 1 is current bus stop next bus, then next bus cbs, and then so we are in next bus and cbs, or what is I? Yeah. And now if target not -1, right, and then return min of this target. Okay, default dict of default dict. So what's up with that? What's your problem, bro? Print type list CBS. Let's. That's weird. That is very weird. Okay, so it shouldn't be a typo, but let's debug it. I don't know. Let's like print. Oh my god! It probably was already screaming through whatever. Ooh, index out of range. How is that possible? How is that possible, my brother? Let's see. Tuple index. Tuple index out of range. What? Okay. Let's see, so every time we finish, we print distances, right? So after we process the first guy, then we get to 1, okay, get to 2, and get to 7 with, not sure why we can get here with, what? That's weird, I guess. I mean, if I do print dict print dist now, then what do we get? I mean, because we got this here. Oh, because I only started source, so why is, oh, the distances should be 1. Okay, now it should work. Okay, it doesn't. That's interesting. So after processing, what? Print cd cd cbs. So 101. What is 101? Current, distance, current bus, and this, right? We process that, and we get 27, and then 216. So what's your problem? Okay, I'm back after 1 hour. want to do too much. Anyways, so something is wrong here, because print list target, let's see, oh, okay, mean x for x in these values. Okay, now let's see how it doesn't work on some actual test case. Yeah, so that's TLE, so there is some cycle. Oh, actually works quite well. Okay, well, that's an edge case. Okay, let's see. But that doesn't explain the other 12 cases, so time limit exceeded. Int, right? And CD is more than or equal to the RS. So if NB is not there, and CD plus 1 is less than or equal to, actually then we should do DRS is CD, and then the current bus stop is maybe, I don't know, and then current distance plus 1 is smaller than or equal to less than distance to the, I mean, it quite doesn't make sense. Actually, and RS in the and RS not in the, or okay. So if bus is not there, and RS not in the, or CBS whatever, or this holds, right? Nice. And CD, okay, now the first one doesn't work. It sucks a little bit. Oh. Let's see. Okay, so after first one you can get there by bus. Let's see, so default dict. I can straight up, by the way, just do this here. Dist int target in dist. Let's see. False. What's target, bro? 6 is target. That's great. Yeah, probably I should do like distance to rs is 1. Okay, and then for some reason we stop after 3 iterations, which seems weird. So if it's not there and the bus stop is not in the, or the distance is less than that, then we can do these shenanigans, right? Then you want to jump to 7, so for neighbor. So if we evaluate first this expression, and so either the bus stop, so the bus stop has to not be there, and then either we have not visited the bus stop at all, or the distance that we can get there is more than that, right? And if none of this is true, so but essentially NB is there, then only we check this, and this should be less, and not sure why I'm opening that, but okay. If CB is 7 and B not in this CBS, okay, doesn't even get to that. Okay. Oh, if CBS is 7. Let's see. Okay. So NB, right? So first the bus number 0 is we cannot get there, right? And now suddenly, oh great, we got there, which does make sense. Okay, let's say we got to 7, right? And then so if CBS, so if we are at 7, right, and next bus stop is, or next bus we take is 0, oh, because okay, so if NB equals CB continue, we don't want that, right? And then what we want to do, see, still will not work, but okay. And then something has to happen, and I'm not sure what it is. Not sure why that is happening though. Okay. Why did I pick a hard problem? So I don't know. I don't know, bruh. We should be what? Should process bus 7, right? And then the next bus should be bus number 1. And now question is this, right? So I wanna print current bus stop, and next bus, and print NB not in this CBS not in D, or let's do it like that. So CD plus 1, probably don't want to show this one, and then okay, let's do these two. Okay. Oh my god, Leetcode is lead coding, as they say. Okay, so we are with bus 0 at here, and we wanna jump to bus this, right? And let's see, so true, right? So that's not there, and now we already go to 7. That's the problem. question is, do we always want to take this jump to some other bus? Yeah, I'm doing this stupidly. Essentially, you just want to jump through buses, right? And what happens? Well, this you can jump bus for free, and here you pay for bus, but you never visit the bus twice. So only way, oh my god. So that's the thing I should be checking, right? Yeah, so this is what I want to check, right? So actually I have distances to nodes, but I reduce it to int, right? And then number of buses it takes. And then used is this. Now question is what we want to add to used. Yeah, we probably want to add these here, because why would we jump ship, right? So used at I, and now if so that means we jump through the same bus, right, which we can do every time. So if CB not in this RS, like that, I guess, but this will allow you to jump anywhere. Not sure. That's bus still visited, right? And now if we didn't get there by that bus, or next bus not in this, so we are always jumping, so we just don't want to do this, I think. And used at whatever new bus, like this. Okay, now it works. So let's comment this out. Okay, let's use this test case. Should run. Okay, it doesn't. So I think the problem is with this, so you immediately want to go to everyone. Okay, I don't want this, because that's very dumb. Maybe, I don't know. So if RS not in list, then this happens. Okay, and now if NB not in used, what does that even mean, bro? What does that mean, brother? So I guess So it's just, I don't know. NB not in dist or CD plus 1 dist. I mean, does that matter? Because, okay, let's say I want to jump there. Right, so I guess I should go by buses. Right, so then dist of this is 1, right? Alright, so we just do BFS on buses, I guess. Right, and distance, that bus is 1, I guess. And then we do like, that's like current distance, current bus, right? And then current bus, and if so we go through its routes, and if it's equal to, I mean, we don't really care through each route, and then we go through this, I guess. So for each route we go to the other ones with this bus, and if NB not in I don't know, distance, right? So that's exactly this. Then dist NB CD plus 1, right? And now we go through ans. This could take like n plus 1 len roots plus 1 for root in roots found, or we can do this. So for stop in root, if stop target return, no, so ans min ans dist enumerate this, and then let's do like bus, okay, this bus, right? And then and the bus in dist break return ans. Let's see. Oh, for new bus in G other in route stop. Okay, now it took 41 milliseconds, but it's not correct, so output is 6 and it should be -1. Okay, let's see your distances. Okay, so distance to 1 is 1 and distance to 3 is 1, right? And then you go through RS of the current bus, go through its neighbors. So from 4, 5 you don't go anywhere, from 19 you don't go anywhere. So how you get to 12? That sucks, bro. You cannot. Okay, so -1 if ans len roots +1 else this. Okay, now it should pass. Okay, and I'm way off. That is crazy, and I think it's because of this. Let's do like okay, G other could stay default dict, but this really should not. And why do I use used for should be like n plus 1. Let's do like this. So inf n plus 1 inf for in range roots len. Okay, let's r len roots okay, range r, right, distance is 1. This CB like this. Okay, ans is inf, if ans is inf else this. Okay, let's try again. Wrong answer many times. That's not looking good, but I feel it. Output -1. So actually, do you want to check busing list? Not really. Okay, let's go. Okay, maybe my check is slow, or I don't know. But at this point, BFS with bus stops, that's probably slow. M squared, okay, that's slow. BSS is routes as nodes. It's still M squared, so you don't want to do that, maybe. M is size of routes. I mean, what if this is 10 to 5? You are cooked. That's weird. Okay, I mean, that was simple enough. I think this is slowing me down a lot. So instead, we remove this distance thing, because we only need like visited, right? And then this add I, okay, and then so if nb not in this, then this add nb and then whatever, right? And now if that is weird. How did he do it? Stop for stop buses in what? I mean, whatever. My time complexity is roots. I mean, technically, okay. And doesn't matter. I don't even have to write this, okay, because I will not be able to submit. Okay, so let's do like bus BFS on buses, O and number of buses, but eventually we might iterate over all stops, so I think it's OS. So let's do a BFS on buses themselves, initially putting all buses with source stop in their routes into the queue when processing a bus. We simply bus, we want to know to which buses can we jump over for each of its bus stops. We can iterate over such bus stops easily if we store an adjacency list gother where gother per stop is a list of where gother is a buses that where gother is a list of buses which visit that stop. For each bus, so for each stop and each bus we can jump to from that on that stop we check if we have already not been there, not use that bus, and if not, we add the bus to the queue. Time complexity is O of, I think, number of stops plus number of buses, where S is the number of stops and P is the number of buses, since for each bus we have to go over its is the stops, and B is the number of buses, since for each bus we have to go over all of its since for each bus we have to go over all of its something. Okay, space complexity is like for each bus stops we append whatever, so I think it's also S plus B. Oh my god, okay. Since we have to store buses for each buses that visit each stop. Okay, I cannot pause that, so goodbye.